Hi, hello everyone. In the today's session, I'm going to talking about a reference electrode. Here, reference, as we know that what is an electrode. So electrode is a metal or metal rod which conduct electricity, right? So that is a metal rod, that is nothing but an electrode. And here we are talking about a reference electrode. Reference, here the reference electrode means, so the electrode with reference to those, the electrode potential of any other electrode can be determined. I mean, so here the reference electrodes are the electrodes with reference to this, with reference to those will measure the another electrode potential. As we know that the cell is a coupling of two electrodes. So here we can take a reference electrode, this is one electrode, and another unknown electrode. The reference electrode means, so we know the value, we know the electrode potential value in that electrode potential value of that particular electrode. So we know that electrode potential value. So by taking an unknown electrode potential value, you can measure the potential. So that is called as a reference electrode. So reference electrodes are the electrodes with reference to those can determine another electrode potential. Understanding here? Yes, and there are mainly two types of reference electrode, or we can say the types of electrodes. But here we are talking about only two types. So mainly it is a primary and a secondary reference electrode. But now we will consider the what are the types of reference electrodes. So the main important types are here. The first one is the metal ion electrode. Metal ion electrode. Metal ion electrode. So here this means the metal is an electrode is dipped into the solution of its own ions. So that electrode is said to be a metal ion electrode. For example, here when copper rod is in contact with copper 2 plus ions, is in contact with the solution, this containing or contains copper 2 plus ions, metal ions, right? Or we take zinc is dipped in Zn2 plus silver, nickel, you take that is a metal ion electrode. So the potential is developed between the electrode and the electrolyte interface. That is a metal ion electrode. Okay. And the second type is a gas electrode. So the best example for this gas electrode is SHE. It is standard hydrogen electrode. You have studied this in the previous class. What is the construction and the working of this standard hydrogen electrode? So here this standard hydrogen electrode, it defines the as zero potential in the electrochemical scale. That is, that gives the zero potential or zero electrode potential. So here is the standard hydrogen electrode. Is an example for primary. Is an example for primary reference electrode. Is an example for primary reference electrode. As we know that in the standard hydrogen electrode, we need to pass the hydrogen gas at 1 atmosphere. But that is very difficult to handle that gas electrode. So we need a well developed technology, and this what we are calling. So this standard hydrogen or gas electrode, by maintaining an installation, that equipment cost is more, and also so handling of this instrument is very difficult. That means we need to pass the hydrogen gas at 1 atmosphere. So that is difficult. So that's why nowadays we are not using this primary reference electrode. But here the electrode potential is arbitrarily taken as 0. So here the standard hydrogen electrode, the electrode potential is arbitrarily taken as 0, or we can say it defines the 0 scale or 0 value in the electrochemical scale. Understanding here? So the primary reference electrode is a standard hydrogen electrode. So that is having a standard electrode potential is arbitrarily taken as 0. Right? And the third one is metal salt ion electrode. That is metal salt ion electrode. So this is very important. metal salt ion electrode. So it is same as that of metal ion electrode. So here what we are doing in this electrode is the metal is sparingly soluble in metal salt ion. Okay, so the metal is sparingly soluble in metal salt ion. So that electrode is taken as metal salt ion electrode. So example for this metal salt ion electrode is Calomel electrode, and silver chloride electrode, AgCl electrode. So commonly taken as this metal salt ion electrode. So here so these electrodes, these metal salt ion electrodes, are also called as secondary reference electrode. This Calomel and silver chloride electrodes are secondary reference electrode. Secondary reference electrode. So here in this electrode, that is calomel and silver chloride electrodes, are also called as secondary reference electrodes. So as I told you, so this SHE, standard hydrogen electrode, is difficult to handle this instrument. So nowadays we are preferring this secondary reference electrode. So we are using the secondary reference electrode. So what is this, how it is constructed, this Calomel electrode? So we will see later. So it is having these electrodes having a electrode potential with respect to this SHE, standard hydrogen electrode. Just remember, the primary reference electrode is a standard hydrogen electrode, and the secondary reference electrode is a Calomel electrode and silver chloride electrode. In your engineering syllabus, we are going to study this Calomel electrode. We are going to study the working and the construction of this Calomel electrode. And even in practical, engineering chemistry practical also, there is one experiment in that we are using this Calomel electrode as a secondary reference electrode. That means that is having a electrode potential with respect to this standard hydrogen electrode. That is a metal salt ion electrode. Got it? And the fourth one is amalgam electrode. So here the metal amalgam is in contact with a solution containing its own ions. So generally we are taking a mercury with another metal, that is an amalgam. We can say that amalgam. So here for this amalgam electrode, we are taking as lead amalgam electrode as an example. So that is lead is mixed with Ag, silver, that is amalgam in Pb2 or lead amalgam is an example for this amalgam electrode. Is one of the type of reference electrode or types of electrodes. And the fifth one is oxidation reduction electrode. Oxidation reduction electrode. So example for this oxidation reduction electrode is platinum and Fe2+. Platinum electrode is an oxidation reduction electrode. In that, redox reaction takes place. Understanding? So this electrode also we are using in one experiment, that is potentiometric estimation of FAS, iron 2+, by using this platinum electrode as a indicator electrode. It is not a reference electrode actually. That experiment we are using this Calomel electrode as a reference electrode. So these two are reference electrode, that is a gas electrode and metal salt ion electrode. And here this oxidation reduction electrode acts as a indicator electrode. Okay, means that indicates the end point or equivalent point. Okay, and the last one is ion selective electrode. This is very very important. Ion selective electrode. As name itself says selective. That means ion selective electrode is very selective towards a particular ion. Suppose K plus we need to calculate, or Na plus, or calcium 2 plus, like that. So here the ion selective electrode is very selective towards a particular ion. Only this I am going to find out, K plus ions. So in that case we are using ion selective electrode. And here whatever the potential is developed, so that is directly proportional to concentration of that ions. Understanding here? Ion selective electrode is very selective towards a particular ion, and the electrode potential is proportional to concentration of that ions. Got it? So here the example is glass electrode. Glass electrode is an example for ion selective electrode. So this electrode also we are going to study here. So in this chapter, that is electrochemical energy system, in that we are going to study the reference electrode, here Calomel electrode, and then glass. These two electrodes we are going to study now. Okay, so these are the basic concepts. At least you should know what is primary reference electrode and why we are preferring this secondary reference electrode while determining the metal ion concentration. Okay, so here the primary reference electrode, in this standard hydrogen electrode, it is very difficult to handle this hydrogen gas at 1 atmosphere. So nowadays we are using this secondary reference electrode as Calomel electrode. Okay, in that mercurous chloride, mercury 1 chloride we are using as a Calomel paste, like that. So here this in this chapter mainly we are talking about a Calomel electrode and glass electrode. Got it? So there are 6 types mainly that we are talking about: primary reference electrode and then secondary reference electrode. So here primary reference electrode, SHE, this standard electrode potential is arbitrarily taken as 0, and this Calomel electrode, by changing the concentration of Cl minus or KCl, will get a different values of electrode potential. So that is a known potential. While keeping the known potential, here is some E value, E naught value is 0 or 0.24. So here we are going to find out the electrode potential of this. We don't know this electrode potential. So in keeping this as a reference electrode, we are going to find out the electrode potential of any other electrode. That is called as reference electrode. What is a reference electrode? So reference electrodes are the electrodes with the reference to those you can find out the electrode potential of any other electrode. In that mainly there are two types, that is primary reference electrode and the secondary reference electrode. Primary reference electrode, for example, standard hydrogen electrode. In that standard hydrogen electrode, the electrode potential of that particular electrode is arbitrarily taken as 0, and due to this difficulty in handling the hydrogen gas, secondary reference electrode is preferred. So this secondary reference electrode, in that the which is having a known potential value with respect to this standard hydrogen electrode. Understood? And next, now we will talk about the construction and working of a Calomel electrode. Right? Yes. Coming to the construction and working of this secondary reference electrode, that is a Calomel electrode. See, observe the diagram here. So, how this Calomel electrode is constructed? So, as we know that this Calomel electrode is a secondary reference electrode, and this electrode is a metal salt ion electrode. Then we have taken a metal as mercury and metal salt as mercury 1 chloride. See, this Calomel electrode is a metal salt ion electrode, and it is constructed by taking a calomel paste. It is this calomel paste is filled into a narrow glass tube. At the bottom of narrow glass tube and having a porous plug at the bottom. A calomel paste, that is mercury 1 chloride paste, is taken, it is filled into a narrow glass tube. This is a glass tube, and there is a porous plug. This is porous plug at the bottom end of the glass tube. And then a liquid mercury is filled just above the calomel paste. A liquid mercury is filled just above this paste, that is a calomel paste, mercury chloride paste. And then to measure the potential, for the measurement of potential of the electrode, a platinum wire is dipped into the liquid mercury. That is, see here, this is a platinum wire. That is gives an electrical constant or electrical connectivity. Here, this platinum wire is dipped into liquid mercury to measure the electrode potential. So here we are taking the electrode. So electrode potential, while measuring the measurement of electrode potential, this platinum wire is dipped into a liquid solution. Liquid mercury, right? And entire this tube, a narrow glass tube, is placed in the outer glass tube. That is also a narrow shaped outer glass tube, and it is containing KCl solution and having a porous plug at the bottom end of the outer glass tube. So that is acts as a salt bridge. And there is a opening for filling a KCl solution for the outer glass tube. So this is how the Calomel electrode is constructed. Once again, here observe carefully. This Calomel electrode is a metal salt ion electrode, as I told you in the types of electrodes. So this Calomel electrode is also called as secondary reference electrode. This is a reference electrode, and this is constructed by taking a calomel paste, or we can say mercurous chloride paste, is taken at the bottom of a narrow glass tube, and there is a porous plug at the bottom end of the tube, and a liquid mercury is filled just above the paste, and there is a platinum wire which measures the potential of the electrode is dipped into the liquid mercury. So this gives an electrical contact, and this entire tube is placed into the outer glass tube that is containing a KCl solution, right? And there is a porous plug for the outer glass tube at the bottom end of the tube. So that is acts as a salt bridge. So this is how the construction of Calomel electrode is made. See, observe, there is an opening for KCl solution. We can change the concentration of KCl solution from this now. From this inlet, we can change the concentration of KCl. And now we will see the working and electrode potential. While calculating the electrode potential, we came to know the electrode potential value of a Calomel electrode depends on the KCl solution taken. And just for the working of this Calomel electrode. As I told you, this is a secondary reference electrode. Calomel electrode is a secondary reference electrode. This electrode can act as anode or cathode. That is depending on the nature of other electrode of the cell. As we know that the cell is having two electrodes is connected. While constructing this cell, so this reference electrode is on one electrode. It is on one electrode, but we know the electrode potential value of this. So that's why we are keeping this as a reference while calculating the another electrode potential for another electrode. Okay, so this Calomel electrode can act as anode or cathode. Can act as anode or cathode. Understanding here? So that is depending on the nature of other electrode of the cell. Okay, when it acts as anode, when it acts as anode, when it acts as anode, what is the electrode reaction? The electrode reaction. The electrode reaction is, here we are using this mercury, so that is mercury with fluoride, which gives rise to Hg2Cl2 plus 2 electrons. By balancing this reaction, multiply by 2. So here is the reversible, it is reversible reaction, it is. So we can put this. Here we can observe which liberates electron, that is an oxidation. When it acts as anode, which undergoes oxidation, right? So here this mercury and chloride, so this mercury 1 chloride, which gives which is reversible for this mercury and chloride. So when it acts as an anode, so this is the anode electrode reaction or anode reaction. Suppose if it is acts as cathode, what is the reaction? When it acts as cathode, as I told you, it can act as anode as well as cathode. The electrode reaction is same here, Hg2Cl2 by gaining of 2 electrons, which gives rise to 2Hg plus 2Cl minus. See, this is the reaction we'll get. So as we know that here gaining of electrons takes place, that is reduction reaction. Reduction reaction takes place. So here when it acts as anode, so this chloride and mercury, it gives rise to mercury 1 chloride and releases electrons, that is an oxidation. When it acts as cathode, reduction reaction takes place. So we can write the net cell reaction also, or net electrode reaction, not a cell reaction. So net cell reaction is same here, we get Hg2Cl2 plus 2 electron, which gives rise to 2Hg plus 2Cl minus. Here it is a chloride. Chloride minus Ar. So this is the net cell reaction, and we can measure the electrode potential now. So in the working of Calomel electrode, so it can act as anode or cathode. That is depending upon the nature of other electrode is coupled with this reference electrode. Suppose we can assume if the connected or coupled electrode, the indicator electrode we can say, so if it is acts as anode, then this electrode can act as cathode. We'll get a cell reaction. Okay. So here the electrode potential, how do we measure the electrode potential? So here only I write, as we know that electrode potential value, that is E is equals to E naught I will write here only, you observe or this construction here. Yes. Yes, listen. So electrode potential, how do we measure the electrode potential of this Calomel electrode? E is equals to E naught plus, at 298 Kelvin you take 0.0591 divided by N into log molar concentration of product by reactant. So here the product is, when it acts as anode, that is Hg2 Cl2. Okay, the reactant is Hg, that is having 2 moles of Hg, and then Cl minus 2 moles of Cl minus. Understanding here? But we know that molar concentration of Hg2Cl2, that is equals to molar concentration of Hg, that is equals to 1 for solid mercury, and this what we are calling this paste. So that is molar concentration is taken as unity. Then N values, 2 electrons are involved. So again we can write it, the electrode potential E is equals to E naught plus 0.0591 divided by 2 into log of molar concentration of, that is 1, this is 1 by Cl, molar concentration of Cl minus whole square. When you take this into the numerator, here we will get, or we can write it as E is equals to E naught plus 0.0591, sorry, minus, when it goes to numerator the sign changes, divided by 2 into log of molar concentration of Cl minus 2. Understand here? Yes. And again we know that log m power n. So here this is taken by using an identity, that is log 1 by x is equals to minus log x. Okay. Or E is equals to E naught minus 0.0591 divided by 2 into 2 log molar concentration of Cl minus, that is because of your log m by n, sorry, m power n, that is equals to log, sorry, n log, and write it as n log m. Okay. So these two gets cancelled. We will get E is equals to E naught minus 0.0591 into log molar concentration of chloride ion, that is Cl minus ion. So this is a electrode potential. So listen carefully, observe this equation. E, that is an electrode potential of Calomel electrode. So that is, the electrode potential is mainly depends on the chloride minus, that is Cl minus ion or KCl solution. When we change the concentration of KCl solution, so the electrode potential also varies. That is, the electrode potential of Calomel electrode is depending upon the concentration of KCl solution taken. Yes, you can observe in this final equation, the electrode potential of Calomel electrode is depends on the KCl solution taken or Cl minus ion. When the concentration of KCl varies, there is a different electrode potential will get. That is, if you take a saturated KCl, concentration of KCl is saturated or 4 molar KCl solution, then the electrode potential value will be 0.242 volt. And if you take a 1 molar concentration, the value will be 0.280 volt. And if you take 0.1 mole, then the value will be 0.332 volt. So this is how the Calomel electrode is constructed, and the working here, the working and the electrode potential value. So finding the electrode potential value. So here you need to observe in the working part. So here the Calomel electrode can act as anode or cathode. See, you can observe, if I take a saturated Calomel electrode, that is 4 molar concentration of KCl solution, that solution is taken in a outer glass tube. Okay, so the electrode potential, measured electrode potential is 0.242 volt. If the other electrode is having a electrode potential value 1.0, or if it is more than this 0.8, 0.5 molar concentration, voltage of the electrode potential value, then this will be varies. That is, this saturated Calomel electrode acts as a anode. Okay, so this is the reaction takes place, oxidation of cell or electrode reaction. If it is acts as an anode, this is the reaction. If it acts as cathode, this is the reaction. And this is an electrode potential or potential of the Calomel electrode. That is, the potential of Calomel electrode value is mainly depends on the concentration of KCl solution taken. You can notice that the concentration varies, there is a change in electrode potential value. Right? Yes. And one more thing, application for this, where we are using this Calomel electrode, or application for this Calomel electrode is, it is acts as a secondary reference electrode. Calomel electrode acts as a secondary reference electrode for all potentiometric estimation. As I told you in one experiment, that is engineering chemistry practical experiment, we are using this for finding the FAs, ferrous ions. Okay, so that is by the use of this, by keeping this as a secondary reference electrode, you can measure the electrode potential of another electrode. And so this Calomel electrode acts as a secondary reference electrode for the measurement of single electrode. For the measurement of single electrode and potentiometric estimation, in that we are using this Calomel electrode. So that is about a secondary reference electrode. I hope you understand these concepts. So if you have any doubt during class, we will discuss. Okay. So watch this video without fail. This is a very important question. Okay. Thank you.